Hello students, welcome to the class of teacher Meenal Pereira. In this video, we will study about two more crystalline forms of carbon, that is graphite and fullerene, and we will also study about non-crystalline or amorphous form of carbon, which are nothing but coal, charcoal and coke. So let's begin. First, let's study about graphite. Graphite is found in the natural state in Russia, New Zealand, America and India. The lead used in the pencil is made by mixing graphite with clay. Okay, so we are very commonly aware of the use of graphite. The lead that we are using in the pencil is made up with graphite. This process was discovered by Nicholas Jacques Content in 1795. Okay, so that time he discovered a black color substance could be used to write on white paper, and that was a graphite. Now coming to the structure of graphite, every carbon atom in graphite is bounded to 3 other carbon atoms in such a way that hexagonal layer structure is formed. Okay, so as you can see here that hexa means 6. So 1, 2, 3, 4, 5, 6. So you can see a hexagonal layer structure because every carbon atom is bounded to 3 other carbon atoms. Okay, so this is the structure. You can see the inside one, and this is how the molecular structure. A graphite crystal is made up of many sheets or layers of carbon atom. As you can see in this diagram also and in this diagram also, we can see some sheet of carbon atoms. These layers slip over each other on applying pressure. One layer of graphite is called graphene. Okay, so a single layer. Suppose this is the single layer. So this is a graphene. And by pressure, these form a complete structure, that is a graphite. Now coming to the properties of graphite. Graphite found in nature is black, soft, brittle and slippery. Okay, so the color is black, it is soft, it is very easily breakable, that is brittle and slippery. Okay, so if you touch graphite with your hand, you will find a soapy touch, that is slippery. Inside each layer of graphite, free electrons move continuously within the entire layer. That is why graphite is a good conductor of electricity. Okay, so we could see in the previous one that in case of each layer, the free electrons move continuously. So graphite is a good conductor of electricity. Okay, so we have studied that. Now see, look, carbon is also a form of, or diamond is also a form of carbon, which is a very bad conductor of electricity. But same graphite, which is a form of carbon, is a good conductor of electricity. Due to the layered structure, graphite can be used for writing on paper. Because of the pressure, the layers are so fixed with each other that it looks like a continuous structure, and we can use it for writing on paper. The density of graphite is 1.9 to 2.3 grams per cubic centimeter. And graphite also does not dissolve in most of the solvent, just like carbon. Now uses of graphite, it is used for making lubricants because it is slippery in nature. It is also used for making carbon electrodes because it is good conductor of electricity. The structure of dry cell you have studied in 8th standard. So you know that graphite is used for making carbon electrodes. And of course it is used in pencil for writing. Then graphite is also used in paint and polish because of its shiny structure. It is used in paints and polishes, and it is also used in arc lamps to give a very bright light. Okay, so arc shaped lights has graphite because of its shiny and bright or smooth nature. It is used in arc lamps with many other chemicals, and it gives a bright light. Okay, so this is all about graphite. Now moving to the next crystalline form of carbon, that is fullerene, which is an allotrope of carbon, is rarely found in nature. Okay, so we don't see this very hardly. It is found in soot and in intrastellar space. The first example of fullerene is Buckminster fullerene C60. This allotrope of carbon is named fullerene after the architect Richard Buckminster Fuller because the structure of C6 resembles the structure of geodesic dome A design. Okay, so you can see the dome or circular shape structure. This is a very rare allotrope of carbon, and the first example is C60. It has 60 carbon atoms joined with each other, and it is given by architect Richard Buckminster Fuller, so therefore it is called as Buckminster Fullerene. Harold Cato, Robert Cole and Richard Smalley were given the Nobel Prize in Chemistry 1996 for the discovery of this carbon allotrope fullerene C60. So then later on, these three people, they did some research on that, and then they developed or they discovered this fullerene. Then other than C16, we have C17, C76, C82 and C86 are other examples of fullerene. Okay, so you can see that it has different physical structures. So C16 looks like a ball, 17, 76, 78, 70, then 78, 1, 2, 3. Okay, so depending upon the number of carbon atoms, you can see the variation in the structure. Okay, these are all the examples of fullerene. Their molecules occurs in small number in soot. Okay, so we have our exhaust pipe that we have in our vehicles. If you touch the inside part, please touch it when it is cold, otherwise you will burn your finger. Then you will get these black color particles which we called as soot, and graphite, sorry not graphite, fullerene occurs in the soot. Now coming to properties. The molecules of fullerene are found in the form of buck balls and buck tubes. Okay, so a ball-like structure is a buck ball, tube-like structure are bucky tubes. Then there are about 30 to 900 carbon atoms in one molecule of fullerene. So we could see such big numbers, C16, C83, because from 30 to 900 carbon atoms. Then fullerene are soluble in organic solvents such as carbon disulfide, chlorobenzene. So this is a form of carbon which is soluble. Diamond and graphite were not soluble. Then uses of fullerene, it is used as an insulator. Okay, so in a wire it used as an insulator. It are also used as a catalyst in water purification to speed up the process. At certain temperature, fullerene exhibits superconductivity. What is superconductivity? It is the ability to conduct electric current with zero resistance. Now you have studied about electricity and resistance. So every material will offer a resistance. But graphite at certain temperature acts superconductor. So no resistance to electricity. So entire current flows from one point to another point. So where we want good current, we can use this. Now coming to the non-crystalline or amorphous form, very commonly we know. Here, as you can see from the structure, the arrangement of carbon atom is not regular. Okay, so because of this irregular arrangement, it looks like a powdered form. So what are the examples that we have is, we have coal, we have coke, and also we have charcoal. These are the examples that we will be studying. So these are the non-crystalline forms. So first we will be studying about coal, which is very commonly we used. It's a fossil fuel. We all know that it's a fossil fuel. It contains carbon, hydrogen and oxygen. Also contains nitrogen, phosphorus and sulfur. It occurs in the solid state. Okay, so you can see that here that coal that we use, it occurs in solid state. But depending upon the percentage of carbon, it is divided into 4 types. The first one is pit. Now what is pit is, formation of pit is the first step in the formation of coal. Okay, now formation of coal, children, is a natural process which take years and years. Okay, it is formed under the earth's crust by applying high temperature and pressure on plants, buried plants and animals. Okay, so step by step it process goes. So formation of pit is a first step. It has high proportion of water and less proportion of carbon. Okay, so therefore it does not give much heat because it has high proportion of water. Then we have lignite, which is the second one, that is pit transfer to lignite due to increased pressure and temperature. It contains 60 to 70% of carbon. Okay, so we can use it little more than the pit. Then we have the bituminous coal, which is formed as a third step of formation of coal. It also contains 70 to 90% of carbon, so we can use it as a fuel. And then we have anthracite, which is no pure form of coal, which has 95% of carbon. So properly we can use this as a fuel. Okay, so depending upon how early we are removing the coal, it is divided into 4 types. And anthracite is the purest form that could be used as a fuel. Then moving to the second form, that is charcoal, which also we all know very well. It is made from animals, from their bones and horns, etc. So coal is made up of plants that were buried inside the earth due to some reasons, volcanic structure or due to aging, whereas charcoal is from animals. The animals were also buried under the earth's crust due to some volcanic eruptions or any other geographical reason. Okay, so this charcoal, some part of charcoal is made up of animals, whereas that is made from plant is formed by combustion of wood and in the insufficient supply of air. Now charcoal that we get from nature is made up of animals, and charcoal, if we burn plant or if we burn wood in insufficient supply of air, then we can obtain a charcoal. Okay, so charcoal we get from both, mainly from animals, that is from the nature, and plants by burning. Now coal is used as a fuel in factories and homes. It is used for obtaining coke, coal gas and coal tar. Okay, coke is not Coca-Cola that you drink. Okay, that is a fuel. Then coal gas is also a fuel. Then coal tar that we use for the roads. It is used in the thermal power plants for generation of electricity. Charcoal is used in the purification of water and organic material. So generation of electricity, we use coal to heat water, okay, and that after heating water it forms steam and then electricity is generated. In details you will study this next year. And it is also used in the purification of water and organic material. Okay, we can form a layer of charcoal through which water is filtered and that can be used. Okay, so this is how we can use charcoal or coal. Okay, charcoal and coal are the similar forms. Okay, so we can use both. Then moving to coke, the pure coal that remains when coal gas has been taken away from coal is called coke. So as I told you, it is not your drinking coke, but once we remove the coal gas from coal, what remains is a coke, which is again black color. Now coming to uses of coke, it is used as a domestic fuel. Okay, so from here all the water contents are removed. Okay, so it's a very good, it can be used as a domestic fuel. Okay, but it is like, so it gives lot of smoke, you can see. Then it is also used as a reducing agent. Okay, so in the factories, reducing agent means to remove oxygen, because oxygen reacts with most of the compound and then we cannot use that. Okay, so to remove oxygen we use certain chemicals, those are called as reducing agents. Okay, so coke is one of the reducing agent. Coke is used in the production of aeroform fuel having a form of air such as water gas. This is a new concept. Okay, so water or air-like fuels, that is called as aeroform fuels, such as water gas, which is CO plus H2. Water gas is a mixture of carbon monoxide and hydrogen. Also producer gas, which is carbon monoxide, hydrogen, carbon dioxide and nitrogen, which is a low-grade fuel gas consisting largely of nitrogen and carbon monoxide formed by passing air or air and steam through red hot carbon. Okay, so these are the new concept, like air-like fuel. Usually we see fuel in the form of water. This is air-like fuel where coke is used. Okay, so that is all about carbon, its crystalline and non-crystalline form. In this video we studied about two crystalline forms of carbon, their uses, properties, that is graphite and fullerene, and we studied about non-crystalline or amorphous form of carbon, that is coal, coke and charcoal. Okay, so we studied about four different types of coals and charcoal and coke properties and uses. Thank you very much. Goodbye.